In this video, we are going to be looking at dimensional analysis, but we are going to be looking at multi-step problems. So instead of just having one relationship or conversion factor, we're going to have at least two conversion factors. And so the first thing that we're going to look at, as you can see, is we have our chart. You need your chart for these problems. And then we're going to start out with two-step SI unit problems. And what I mean by SI unit problems is going to be ones that you have your base unit of grams, liters, moles, whatever, and then you're using these specific prefixes. That's what I mean. Now, you might be thinking to yourself, well, how do I know whether something is a one-step problem or a two-step problem or however many steps? So for SI unit problems, the number of prefixes equals the number of steps. So for example, if we had 75 kilograms to grams, so we were asked to convert 75 kilograms to grams, in this I see one prefix. So one prefix equals one step. But now, let's do an example. Let's say we're told that we need to convert 75 kilograms to milligrams. Well, now I still have the K in front of the gram, but what is different with this problem compared to the one above is that I now have a prefix of milli. So, because I have two prefixes, that means that this is a two-step problem. Now, we're going to go through and we're going to use our guess method just like we have been. So, we start out and our given is going to be our 75 kilograms. Our unknown, or the thing we're trying to get to, is going to be milligrams. And again, we don't necessarily know how many milligrams. We just know eventually our unit has to be milligram. So, we're going to start with the kilogram for my unit path, because again, I always start with the units that I'm given. And now, here's where this is different. Now, you're probably thinking, well, I can just go from kilogram to milligram. No, you can't. Okay? And the reason why has to do with our factors that are associated with our prefixes. If you remember, we are only using positive exponents, and because of that, we have to go through the base unit, meaning that the base unit in this problem is going to be the gram. Or I like to think of it, it's the thing that they have in common. So we have to go from the gram, then we can go to the milligram. So you want to write yourself a note that you have to go through the base unit. So again, you can't just go kilograms to milligrams. If you do, you'll get the problem wrong because your factors will not work out right. Okay? You have to go through the base unit. And because of that, you're now not only going to have one relationship, you're going to have two relationships. So the first one is going to be when you go from your kilograms to grams. And then the second one is going to be when you go from grams to milligrams. And again, you're going to use your chart. So this chart here, the bigger one gets the 1, and then the other gets the factor. Okay? And now we have our next step, which is to substitute and solve. So we're going to start out with our given. If I start with my unit of kilograms on the top, then my unit on the bottom has to be kilograms. And then I'm going to have grams on the top. And you might be like, well, how do I know that? That's why we have the unit path. So we started with kilograms. We're now in grams. And our final destination is going to be milligrams. So if I'm here, and again, you can do this so that you know your units. So if this is the gram, if my unit of gram is on the top, my unit of gram has to be on the bottom, and then the unit I'm trying to get to is milligram, it goes on the top. And now we just plug in from our relationship. So 1 was with kilogram, 10 to the third was with gram, 1 was with gram, and then 10 to the third was with milligram. And whenever you plug this into your calculator, you're going to have 75 times 10 to the third times 10 to the third. And that is going to be 75 with 6 zeros. And again, remember, you have to include your unit or else you are going to be wrong. Now, I do want to briefly show you that if, in theory, you somehow tried to go straight from kilograms to milligrams, you would end up having 10 to the third over 10 to the third, and those would cancel out. So that's why you have to do this in the way that we do it. Okay, so let's do another example. So this time we want to convert 150 centimeters to micrometers. So we start out with our given of 150 centimeters. Our unknown, or the thing we're trying to get to, is going to be so many micrometers. And then we have to figure out our path for our units. So we know we're going to start with centimeters. Now, the question is, can I go straight from centimeters to micrometers, or do I have to go through something else first? If you answered something else first, then you are correct. This is a two-step problem because I have 2 prefixes. So that means I have to go through the base unit of meter, then I can go to micrometers. And again, I'm going to have 2 relationships. So blank centimeters equals blank meters equals blank micrometers. And I use my chart and I plug in. So meter is bigger, centimeter gets the factor, meter is bigger, micro gets the factor. And then when we sub and solve. So I start with my given of 150 centimeters. If centimeters is the unit on the top, then centimeters has to be the unit on the bottom to cancel out. I have meter on the top because that's what I'm trying to get to in the middle. And now, and if it helps you to go through and kind of do that so you can see that, hey, those units have canceled out. I'm now in the meter. Then if meter is the unit on the top, meter has to be the unit on the bottom, and the unit I'm now trying to get to is micrometer. So it goes on the top. And then we plug in. So 1 was with meter, 10 to the second, 1, 10 to the sixth. And whenever you plug this into your calculator, you would have 150 times 1 times 10 to the 6th. And you don't necessarily have to include that 1, because anything times 1 is just going to be itself. And then on the bottom, you're going to have your 10 to the second. So when you type this into your calculator, you're going to end up with this as your final answer. Okay, now that's what happens whenever we are dealing with our SI units. But let's talk about, well, what do I do if I have a multi-step when my conversions are given to use? So now not all of them are going to be given, but some of them are going to be given. And it's important to note here that the conversions you're getting ready to see a lot of times are going to be used with cooking. So cooking is a great example of a practical use of dimensional analysis. For example, converting between teaspoons and tablespoons, or milliliters to gallons, and things like that. Because a lot of times, you only have so much of something and you need to figure out different units and things like that. So cooking is a very real application of dimensional analysis. But let's say in this problem, so this is an example. Okay, we need to convert 9.6 milliliters to gallons. And we are told that 1 liter equals 2.64 gallons, and that we need to have 7 decimal places in our final answer. So we're going to start out same way we always do. Our given is going to be this 9.6 milliliters. Our unknown is going to be however many gallons. And then this is where we get a little bit different. So with our path, we know we're going to start with 9.6, or start with our milliliters. But from there, can I go straight from milliliters to gallons? Like, do I have a conversion that is given to me that says so many milliliters equals so many gallons? No. I have 1 liter equals so many gallons, which means I'm first going to have to go to the liter, then I can get to gallons. So guess what? This is going to be a 2-step problem, because I'm first going to say blank milliliters equals blank liters, then blank liter equals blank gallon. And that is actually given to me. So the fact that 1 liter equals 0.264 gallon. And then over here on the other side, the liter is bigger, and then milliliter is going to get the factor. And then we just substitute in and solve. So we're going to start with our given. If the unit of milliliter is on the top, then the unit of milliliter has to be on the bottom. And the thing I'm trying to get to is liters, so it goes on the top. And now, if liter is the unit on the top, liter has to be the unit on the bottom. And then the unit I'm trying to get to is the gallon, so it is now on the top. And then we just plug in. So here's 1, 10 to the third, 1, 0.264. And now you're going to get a kind of large number with all the decimal places when you do this, but your final answer should be this. Okay. And then last one that we're going to do involves, whenever I think of this, I think of my gas mileage, because it's going to involve miles per gallon. So this example is to convert 9.4 kilometers per liter to miles per gallon. And you might be thinking to yourself, I have never seen anything like this. Okay. Now, we are also given these conversion factors. So 0.621 miles equals 1 kilometer, and then 1 gallon equals 3.785 liters. Now, the first thing that we're going to do is we're going to set this up just like normal. So we're going to start out with our given, which is our 9.4 kilometers per liter. And then our unknown is however many miles per gallon. Now, for this one, because we have like our 2 units basically, one over the other, meaning the kilometers over the liter, I personally think it's easier to just go ahead and combine the E and the S step in this one. So we're going to have 9.4 kilometers, and it's important that that is over liters. Now, before we get into solving this, okay, I want you to think about, how can I cancel out units? Well, in order to cancel out units, you have to have the same unit in the numerator and the denominator. Meaning that if I wanted to cancel out kilometers right here, I would have to have kilometers in the denominator. But if I wanted to cancel out liters, since liters is already in the denominator, liter would have to be in the numerator. That's important, because if I start with kilometer as unit on the top, kilometer has to be the unit on the bottom. Well, the only thing that I'm given is kilometers and miles. But now I'm then given that I have miles on the top, which is what I want. Eventually, I want miles on the top. And I eventually need gallons on the bottom. So if I need gallons on the bottom, and keep in mind, this is canceled, this is canceled. I want mile on the top, gallon on the bottom. I'm going to have to put the liter up here in order to cancel out with this liter over here. And then I'm just going to plug in from my conversion factors up here. So 1 and then 3.785. And whenever you plug this into your calculator, you round to 2 decimal places, you should get 22.09 miles per gallon. And again, the biggest thing with this dimensional analysis, whether it's a 1-step problem, a 2-step problem, you're given the conversion factors, regardless of that stuff, is your units. Your units have to cancel out. And the way that they do that is they have to be the same units in the numerator and the denominator. Doesn't necessarily matter, as we saw in this last example, where in your problem that they're on the top and the bottom, but they have to be on the top and the bottom in order to cancel out. And that is it for our multi-step dimensional analysis problems.